All right. Our last speaker before the coffee break, and I want to introduce next speaker, Wei Xu. He is the chief scientist of Horizon Robotics. Before that, he was a distinguished scientist of Baidu for almost 5 years. And before Baidu, he was a research scientist at Facebook. So let's welcome Wei.
Okay, good afternoon, everyone. Today I'm going to talk about the language learning in an interactive and embodied setting. In 1950, Alan Turing proposed now the very famous Turing test. And a less known fact is that he also proposed a way to attack this problem. Here is what he said. Instead of trying to produce a program to simulate the adult mind, why not rather try to produce one which simulates the child's? If this were then subject to an appropriate education course of, then one would obtain adult brain. There are several merits for this approach. First, because for adult human, they can do a lot of different things. It will be very, very expensive and difficult to individually solve each one of them. And second merit is that by emphasizing that all the skills and the knowledges of the machine are acquired from its own learning experience, we can make sure that the machine will be able to learn skills and the knowledges that are unspecified at the design time, which is very, very essential for artificial general intelligence. And the third point is that by doing the learning in a developmental way, the machine will be able to proceed from easier tasks to more complex tasks. This can make the learning easier because this is pretty much like the curriculum learning, which is found to be very, very effective in many machine learning tasks. And why do we want the learning to be embodied? For the embodied learning, the learning experience comes from the machine's own physical interaction with its own environment. By actually doing things and observing its effects, the machine will be able to learn lots of common sense knowledge from its environment. And this kinds of common sense knowledge is typically very hard to be captured by the rules or by a static data set. And one great example is a self-driving car. And I think very recently, Waymo just announced that their total driving mileage has exceeded 10 million miles. Yet they are still not ready for full deployment. And we all know that from our own experience, as a human, we can learn to drive very well with just a few hundred miles practice. What's the difference between machine and human here? The major difference is that human from their past experience has lots of common sense knowledge about the world. Even before they start learning driving, they already know what kind of situation is dangerous, like what kind of obstacles should be avoided. And for example, you need to be extra cautious when like, children is around and so on. And for machine, this kind of common sense knowledge has to be either to be coded by rules or from a huge amount of driving data. That makes it very, very difficult. Oh, sorry. And the third thing is that by learning in an embodied setting, the machine will be able to connect the language with what is perceived, with the events and the objects in the environment, so that it can correctly use the language and understand the language. And why do we want to have the learning to be interactive? And there are several reasons. The first is that because we want the machine to be able to interact with human, it needs to be able to use and understand the language very effectively during the interaction. And actually, it will be very much easier for human to teach machine directly using language instead of writing code. And humans themselves are very good at teaching because they can adapt the teaching based on the, by observing the progress of learning of the learner. And also, in order to correctly use language, the machine need to be able to try to learn the effects of speaking by actually observing the feedbacks from its conversational partner during the interaction. And last but not least, during the interaction, the machine will be able to learn the human value, which is also very important because we want to make sure the machine can do things according to the human value and basically want to help human to achieve their values. So here, these are all the motivations we want to do the learning in interactive and embodied setting. And for the rest of the talk, I'm going to talk about some of my recent works along this direction. Okay, for this one, so we are doing trying to do answering questions and following commands. This is the work we published in this year's ICLEAR conference. For this work, we tried to study several things. First is to see whether it's possible to learn to follow the commands using the end-to-end reinforcement learning without any pre-training for the vision or language. The second thing we want to study is whether training the question answering together will actually help the agent to learn follow the navigation more efficiently. And the third thing we want to see is that whether the agent can have the generalization ability about a language, for example, whether it can understand a word in a different context, which is a very important language capability for human. So here is our problem setup. That during training, we have this simulator generate some 2D environments and also issuing navigation commands and also the questions. And the learning signal our agent received is the answers to the questions and also the rewards, which indicating whether the agent successfully execute the commands or not. And during testing, we have two kinds of testing scenario. One is to try to see whether the agent can understand the new word combinations which never seen in the training. Like here, for example, here this yeast and avocado. Let's see whether it's the point. Yeah, the yeast and avocado they have never appeared in the training. We want to see whether the agent can still understand this kind of new combination. And another kind of a scenario is the word appearing new context. Here, so the watermelon never appears in the training commands nor the training questions, but it only appears in the answers. So we want to see whether it can understand the watermelon, this kind of words in a totally different context. So here is our high-level model structure, which I'm not going to go into detail. But what I'm trying to say is that we designed the model structure in consideration of the kind of generalization capability we want the agent to have. And the whole model is trained using deep reinforcement learning together with supervised training for the question answering. And here is our experiment result. Here is the curve, or the average reward curve along during the training. And the red one is our method, and we compared with many other existing models structures which are mostly adapted from the visual question answering literature. And we can see that our model is better than all the other existing model structures. And one thing I want to note here is that with the question answering task is actually very useful for helping the agent to learn the navigation. Without training the question answering, the performance drops a lot. And here is what we really care about is the generalization ability. And here for the left side, we test the generalization ability for the new word combinations. And we can see that our model outperforms our other models. And in a different scenario where the word appears in a new context, all the other models actually performs very, very bad. And our model still can understand this word in a totally new context. And here now we change the problem a little bit. Previous work, we have this agent trying to do things in the 2D environment. And here we want to move to a more realistic 3D environment. In this 3D environment, there are several challenges. One is first, it's partially observed because the agent cannot see everything in the environment. And the second thing is that because the action is more fine-grained and it takes much, much longer to get the reward, which makes the reinforcement learning much more difficult. And the third challenge is that because it's a 3D environment, the visual part contains lots of variations compared to the 2D environment. And for this problem, we focus on improve the fusion of the language information and the visual information. And for this purpose, we designed a module called Guided Feature Transformation to specifically for the fusion of language and the visual information. But basically what it does is to do some kind of language-dependent transformation of all the visual feature vectors. And here we compare our methods with many other methods for fusing the language and vision. And here the GFT is based on our method, and we can see that our method outperforms all the other methods in both 2D and 3D environments. And here's a short video demo about to show how our agent navigates according to the instructions. Here the current command is please move to the object that is in front of the basketball. And we can see that from this angle, there's nothing in front of the basketball, but there's a toilet paper beside the basketball. So actually, in order to successfully execute the command, the agent has to approach the toilet paper from a direction where it's actually in front of the basketball. So this kind of understanding is trained through this deep learning, like in an end-to-end fashion. And after it finishes new command, it will get a new environment and different instructions. Okay, so far we have this agent which is able to understand the language and execute instructions. Another thing we want to look at is whether the agent can actually use language or not. And here, this is the work we published in this year's ACL conference. And in this work, we're trying to see whether we can make an agent to learn to speak by having conversation with its conversation partner. And we also want to study what kind of information the agent can remember during the conversation, and whether it can utilize the knowledge in its memory to help it for the conversation. So here is our problem setup. At the very beginning, our agent have zero understanding of knowledge. It can no understanding. It cannot use it. Just like here, it can only generate some like random garbage thing, just like a newborn baby. And we have this virtual teacher which is trying to talk about things in the environment, ask questions. Basically, she wants to teach our agent to have some meaningful conversation. We hope that our model will be able to let the agent able to learn to use language through this conversational process. And during test time, we'll test our agent. During the test time, the virtual teacher will talk about some new stuff. And we hope we want to see whether our agent can understand that during the test or not. Here is our high-level model structure, we have this, in the center, we have this memory module, which is used for store information about this visual information and the text language information. We have this vision module basically is a convolutional neural network which can generate the visual representation. And have this interpreter module which is responsible for the understanding of the utterance from the teacher and also make decision to whether to store the relevant information to the memory module or not. And also the speak module is responsible for generate response based on the understanding and the information retrieved from the memory module. And the training signal is, one is the reward, which indicates whether response is appropriate or not, and also to predict what the teacher is going to say. And this is the model detail, which I'm going to skip. So here's some example dialogues where we can see that this is the dialogue before the learning. We can see that this learner just generated some garbage things like a newborn baby. But after the learning, these are the dialogues after learning. We can see that there are some behaviors it learned. For example, like it can confirm the statement from the teacher. It can also ask proactive ask questions, information from the teacher. And also it was able to remember information from the teacher and use that information for later answering the questions from the teacher. So like what I want to emphasize is that all of the behaviors, unlike other chatbots, which their behaviors are pretty much defined by human design. Here, all of these behaviors is learned through this conversational process. It's not pre-programmed, just like what like child learn their language from their parents. Okay, here's a summary. So what we have now is an agent which is able to learn to understand and use simple language, and also it's able to memorize useful information and execute simple commands from the interactions with a virtual teacher in a virtual environment. What we want to do in the future is that we want to move from the simple to complex, from virtual to real. There's going to be lots of challenges for achieving that, but it's also going to be very, very exciting. And in the final slides, I want to give a very short introduction about AI research at my company, Horizon Robotics. The company is like a technology powerhouse for the edge AI platform, and what it's focused on is providing algorithms, processors, and hardware jointly optimized for the high performance, low power, and low cost edge AI platforms. And I want to share with you the good news is that we just get the CES 2019 Innovation Award for our AI platform. And we have 2 AI labs in Silicon Valley. And one is called Generalization AI Lab, which is focused on doing the long-term research for the company's long-term vision towards artificial general intelligence. And basically, it's doing kind of things I just talked about, building machines that can learn skills and knowledges unspecified at design time. And we have another lab called Applied AI Lab, and it's doing research focused on the near-term needs of the company. And it's developing AI technologies that are critical to our current products. And we are active hiring. If you are interested, please go to these websites. Okay, thank you.
Thank you. We have time for 1 or 2 questions. Anyone have question? And the volunteer will give you the mic.
Hi. Hello.
Yes.
Yeah, it's a very good presentation. And I had some question while watching your presentation. Like you said here, human is teaching the machine without pre-programming. But when human is teaching, the vocabulary must be limited, right? I mean, and also humans should understand that vocabulary. So yes. Maybe move, go, I mean, it cannot have unlimited vocabulary, some limited vocabulary. That can be learned by the machine. It's not that, and also language is important, right?
Right. Yeah.
Okay.
Yeah. So I think as I said, moving towards like using the real human to the teaching is our what we want to do in the future. So because currently we only use a virtual teacher to generate the commands or questions or the dialogue. So it's the kind of dialogue the virtual teacher is able to generate is kind of limited because it's based on some relatively simple grammar compared to a human can use. But I think our general methodology is not limited to the vocabulary size, but whether actually it will be able to actually learn from a real human, we have to, because for real human there's other challenges, like because human, they won't, currently our machine still needs to have this, the interaction has to be much longer compared to actual human. So if we want to use real human to do the teaching, then the machine needs to be learned much faster. So that's the first problem we want to tackle first. Yeah.
I think we're out of time. Let's thank the speaker. Our coffee break is coming up.
Thank you.
Okay.